your frequency response. So yeah, in last class we have dealt with your frequency response. So we have seen what is frequency response and its properties. And before that, we have did a problem with respect to your DFT. What is DFT? So how we can get from your normal Fourier transform, how we can get your DFT we have seen. Okay. So in today's class, we are coming to the end of your second unit. Okay. So this in today's class we'll be dealing with your Cauchy's residue theorem. Okay, so this is one important theorem from where you can expect many gate questions in this criteria. This is some important theorem. You just write it down. Okay, so here you can see it. Okay, so you just write it down. What they are saying about this Cauchy theorem, first you have to know about it. They're saying if f of s, f of z, okay, f of z is nothing but your discrete function. Okay, if this f of z is an analytic function. Okay, so analytic in the sense I'll be saying what is meant by analytic. Analytic in a closed curve C. Okay, analytic in a closed curve C, except a finite number of poles. Okay, within C, then you can find as per your Cauchy residue theorem, your function. Okay, your function within your closed curve. Within your closed curve will be given by this solution 2 pi into I into, that is product of sum of all residues at poles within C. So what they're saying is, first you have to know if f of z is an analytic means. So analytic means what you have to know means, analytic means the function is what you can say, function is you can plot the function in a graph. Okay, analytic in the sense that function can be, we can able to plot it in a graph. That is either you can say it is a, either it is a hyperbolic, parabolic, or a ellipse, like that. So if it is possible to say the nature of the function means, it is called as an analytic. That too in terms of mathematics you have to see. Okay, so if you are saying like that means then the function is analytic. Then this function, the second condition over here, what you have to see is this function must be analytic within the closed curve C. For example, you can see, you can take here. That is, if you can take a circle, okay. So this is a circle, okay. So this is, you can take this as a closed curve C, and the function f of z, the function f of z, can take it as the f of z, you can take it as x minus that is the x minus a you can have. Okay, so over here this a will value will be if this is a unit circle means, okay, if this is a unit circle means 1 means, if your a value is less than 1, that is if your a value is 1 by 2, that is it is 0.5 means, okay, so this function, okay, this function is within your unit circle or your closed curve C. You understand, right? So that's the meaning of that definition. That is, if f of z is an analytic, so the function what I have shown you was an analytic function. If f of z was an analytic, that too it was in a closed curve C. Okay, it was in a closed curve C. Okay, and the another third condition. Okay, this is what your first condition was. First condition was f of z must be of analytic. So second condition was it must be within your closed curve C. Now the third condition is that, third condition what they are saying, it must, the number of poles must lie within the curve. Okay, that is the poles of this function. poles of f of z must be within this circle. We are dealing with the problem, it will be getting clear. Okay, so it must be within this circle. Okay, then the solution for f of z, okay, that is the solution for f of z, the integral over f of z. So integral is nothing but the overall area of the function. Okay, overall area of the function. Then f of z dz will be equal to 2 pi I, 2 pi I into sum of all residues at the poles within T. So if you are dealing with the problem, you might have some clearance. So this Cauchy residue theorem you have already learned in your mathematics. Okay. So the same thing what you have learned in your mathematics will be applying over here, but in a little bit different manner we will be applying over here. So we'll be getting into it. So before getting into that, you just write these things. Okay, you just write these things. So I'll be explaining to you. So you just write it out. F of z dz equal to 2 pi. Okay, you just write it out. You just take it down. We'll be getting into it. So what they're saying is it was the first thing. So the first thing was I have explained previously. It is 2 pi I into sum of your residues. That's what they're saying. So the second thing is if z is equal to z naught. Okay, they are comparing with a simple pole. Okay, if z is equal to z naught, that is you are taking a simple pole means then the residue value, that is the residue of f of z naught will be equal to limit z tends to z naught, okay, z tends to z naught, z minus z naught into f of z. So this is one formula. Okay, so this is for a simple pole. That is, if your pole is having is of order one, if your pole is of order one means you have to take like this. At the same time, if your pole is of a higher order, okay, so if your pole is of higher order m means, if it is of higher order m means, your formula will be 1 by m minus 1 factorial limit z tends to z naught d of m minus 1 by d z m minus 1 into the same thing z minus z naught, but it is raised to the power m into f of z. Okay, so this is what your formula for your higher order pole. Okay, so now we can jump into the problem, then you will be able to understand clearly. Okay, just take it down. Evaluate the following signal. They have given the signal. The signal is 1 plus z, 1 plus z, 1 plus z by z into 2 minus z dz, where c value they have to give. Okay, c is your closed surface. You have to, they will be giving the closed surface value. Okay, so the closed surface value is they have taken z equal to 1. Okay, so this z equal to 1 in the sense, so generally, so this, up to this only your question. Okay, so as per your theorem, first what you have to know is that if f of z is analytic, you have to know. So it is in the analytic, if it is so normally the problems what they will be giving to you will be of analytic only. So you no need to get worried about the function is either analytic or not. Okay, so if they are giving in any kind of out of range, the function is defined for any kind of out of range values only, you have to worry about it. Otherwise, no need. So the second thing is that it must be analytic in your closed curve. Okay, so you have to know about the closed curve. Okay, so the closed curve what they have given was the magnitude, that is z will be equal to, that is modulus of z will be equal to 1. Okay, so that's what they have given. So over here, if you're seeing means generally how you can find the circle or the closed curve means, so it will be written like this: z minus a will be equal to r. So where r is your radius. Okay, so a is your center. So here your a value is 0. So your center is 0. So 0. So radius is your 1. So which contributes to modulus of z equal to 1. So this is nothing but a unit circle. Okay. So this is nothing but a unit circle. So we'll be getting into the problem, then you can understand. So the function is given as p1 plus z by z into 2 minus z into dz. So they might be asking to find your using residue theorem. They might be asking to find this. Okay. So first, you now we have got it. Z is equal to 1. So now we draw the unit circle. So they, we have inferred that it belongs to a unit circle. Okay. So it is a unit circle. So this will be your real part, and here it will be your imaginary part. And over here it will be your real part, followed by your imaginary part. So now what happens is that the radius from your center, so they have given the center is 0, comma 0. So from this to this part will be 1. So now what you have to do, you have to first locate the poles. Okay, first our step is to locate your poles. So solution, you just get it out. So locate the poles. So locating the poles means so can you give the poles of this function in the chat box? Can you give the poles of this function in your chat box? You can just type it out. Just type the what are the pole values of this function. F of z they have given us 1 plus z by z into 2 is 2 minus z. So I am asking a simple control system concept regarding the poles and zeros. So what are the poles of this function? So type it in the chat box. So I think all the 11 students are also sleeping, I think. So I didn't get any kind of response in the chat box. So if you still don't know about poles and zeros, you have to go and see your control system uh, notes. Okay, so I can't do anything regarding that. So you just refer to your control system note regarding your poles and zeros. So then only you will be able to understand. Otherwise, it's very difficult to understand this entire subject itself. Okay. So over here you have to see out your denominator for your poles. Okay, you have to see out your denominator for your poles and zeros for your you can say zeros for your numerator. So this will really belong to your poles. Okay. So from this, what you can infer is that there are two poles. So it contains two poles. So one pole is z equal to 0 and other pole is z equal to 2. Okay. So 2 minus z, you have to give it, we have to equal to 0. So you'll be getting z equal to 2. So now what happens is that you have to plot these two values, okay, to find you are getting finite number of poles. So as I said, you have got a closed curve, but you have to check it out with whether the poles are finite. Okay. In order to check it out if the poles are finite, you have to locate these points in over here. So it is your z plane. So you have to locate these points in a z plane. So if it is 0, is within this unit circle. Okay. So this value you can take it out. So but if you are coming to the next value z equal to 2, it goes out of the circle. Okay. So the z equal to 2 gets out of the circle. So what you can do is you can generally omit this value. Okay. What you have to say is your value must be within this unit circle. Okay. That's all. So now what you have to do is you have to apply the formula. What formula you have to apply? You have to apply this formula. So generally the formula is T f of z equal to dz equal to 2 pi I into sum of residues. Okay. So you have to find the residues. So here the possibility is only one residue. This residue won't be possible. Why means it is outside the unit circle. So what you have to do is you have to find the residue for this. In order to find the residue for this, you have to put is the formula is if I'll be rewriting the same thing. Z equal to z naught is it is a simple pole. It is a simple pole. Okay. So residue f of z naught will be equal to limit z tends to z naught at z minus z naught into f of z. So here your z naught value will be tends to 0. Your z naught value is 0. So if I am putting that means we'll be getting residue f of 0, okay, equal to limit z tends to 0, z minus 0, okay, f of z you have to directly apply. So 1 plus z by z into 2 minus z. Okay. So now this becomes z minus 0 is there. So this z and this z gets cancelled. Okay, gets cancelled. Then what you have to do is you have to put z equal to 0 over here. So what you have to do is, so you're putting z equal to over there means because it limit your z value tends to 0. So 1 plus 0 by 2 minus 0. So finally you'll be getting the value of 1 by 2. So now we got one of the residue of so second residue is not possible in this problem. Okay. So now directly substituting the formula, T f of z into dz will be equal to 2 pi I. Okay. So into summation of residue means sum of this 1 by 2 plus something else will be coming, but that is nothing but 1 by 2 plus 0. Okay. So now this 1 by 2 and 2 get cancelled. So final answer will be pi to I. This is your final. Okay. So it's an easy problem, but they might be sometimes twisting it out. Okay, but the formulas are very simple thing. Okay? So this is about one problem. Now we'll be moving to the second one. Okay? So I think this belongs to example number 16 and we'll be getting to example 17. So this is another one interesting problem. Example 17. So the signal given is signal. This T might be sometimes they might be saying it as a closed curve, or sometimes they might be saying it as a contour. TON. Okay, just take it out. So cos z by z minus pi by 2 the whole square into dz. So here they are defining the contour or the closed curve as t belongs to z minus 1 equal to 1. Okay. So here, okay, so to solve, this will be your f of z. Okay, so solve f of z by your Cauchy residue theorem. By Cauchy residue theorem. Get into the solution. Okay. So first, what I said, you have to define the contour. Okay, so if you're defining the contour means e equal to z minus 1 equal to 1 they have given. Okay, so generally, what you have to do is that you have to take this thing, you have to take this part. Okay, you have to take this part and you have to equate it to 0. So then it becomes yeah. So if you are taking that means and equating 0 means z minus 1 equal to 0. So your z value will be 1. Okay. So sorry, so this takes the value 1 comma 0. So what you have to do is that you just leave this. Okay, you just leave this. It might be confusing. So you just stick on with the other formula what I had given. So the other formula what I had given was this is the thing. That is the z minus a equal to r. So where this r is your radius, okay, and this one a will be your center. Okay, you just stick on with this. Okay, so now what you have to do is just substitute over here z minus a equal to r, right? So it will be z minus 1 equal to 1. So here your center is this point 1. Okay, so here your center is 1. Okay, so it is your center and this is your radius. Okay, this is your radius. Okay, so now if you are drawing means the center value will be 1 comma 0. So here why it is coming with 0 in the sense means, okay, here why it is coming with 0 means if it takes any other value, that is if here it is putting 1 plus the 1j if it is given means, then this j value will be correspond coming here. Okay, but over here it is 1 plus 0, 0j, so your 0 will be coming here, so your center will be 1 comma 0. Okay, so now you draw the unit circle. When drawing a unit circle means or contour. Sorry, here you have to say with respect to your closed curve. Okay, so put as here comes your 1 comma 0. So radius is 1. So here it will be coming with 2 comma 0. Okay, and this it will be 0 comma 0. So your circle will be in this fashion. Okay, so now we have got your closed curve C. Okay, now we have got your closed curve C. So next what you have to do is with respect to your poles. So as I said, your poles are nothing but your values which are at your denominator. So poles are z minus pi by 2 the whole square. Okay. Not you can put this z minus pi by 2 into z minus pi by 2. So your z will be taking the value of z equal to pi by 2 comma pi by 2. So this is your value. Okay, this is your value of your poles. Okay, z equal to pi by 2 means it is nothing but so pi value you put 3.14 by 2, so it is nothing but your it will be getting around somewhere around 1.5 you will be getting. Okay, you will be getting somewhere around 1.5 you will be getting. So now what you have to do is this 1.5 will be over here. Okay, so around here itself there is two poles. Okay, so around here there is two poles. The poles are generally represented by dot. Okay, so here comes your pi by 2 value. And now the next step, what you have got, so your two poles are also is inside your unit circle. So we have got it. So there is possibility of two residue values. So we'll be getting into the residue values. So this residue value is not a simple pole. So it is of what you can say. It is of pole of order m. So if z equal to z naught is pole of order m means your formula will be residue if z naught will be equal to 1 by m minus 1 factorial into limit z tends to z naught. Okay, z tends to z naught. So d, that is differentiation value, m minus 1 by d z m minus 1. That is the order of your differentiation is given. So z minus z naught into m into f of z. So this is your formula. This is your formula. Okay. So now the next step what you have to do is you have to apply your m value, m and z naught value. So your m value is 2 and your z naught value is pi by 2. So if you apply means so residue of f of pi by 2 will be equal to 1 by 2 minus 1 factorial, which is nothing but your 1 factorial, limit z tends to pi by 2. So 2 minus 1 we can put it out 1. So d by dz into z minus z naught. So z naught value is again pi by 2 into m is nothing but your 2 value is 2. Okay, square. So now we have to put the function z cos z by z minus pi by 2 the whole square. Okay, so in general the function and these two value will always be cancelled out. Okay, these two value will be always be cancelled out. Okay, be getting like that. So now we'll be getting limit z tends to pi by 2 t by dz of z into cos z. Okay, now we have to differentiate by this thing. So this is nothing but uv. So uv dash plus vu dash. If you're differentiating d into uv means it will be uv dash plus vu dash. Okay, so you can just write it out uv dash plus vu dash. Okay, and just have it in the mind. So applying means we'll be going with limit z tends to pi by 2 z into, so differentiation of your cos z will be minus sin z plus cos z into 1. Okay. The differentiation of your constant will be nothing but 1. Sorry, constant not variable. Okay, z is a variable. Differentiation of any constant will lead to 0. Okay. So now what you have to do, you have to substitute the value of this pi by 2 over here. It becomes pi by 2. So minus of sin pi by 2 is nothing but 0. So 1. Minus the sin of pi by 2 is 1. Just the cos pi by 2 nothing but 0. You'll be getting a minus pi by 2, what here, residue of f of pi by 2. So now the next step what you have to do is you have to go to the, you have to put there in the final expression. Okay, if you're putting in the final expression means what you'll be getting is you'll be getting okay. So your f of z f of z into c d z will be equal to 2 pi I 2 pi I okay 2 pi we have put so into sum of the residue. Okay, so we have got this is for residue function. Okay, so if you're putting the sum over here means will be 2 pi okay, into minus pi by 2. Okay, so here what you have did was the two poles were same. So here you can take the same residue. So here it will be coming at only single time. It won't be coming double time. So make it clear. So you have to put it at one time. So this 2 and 2 will be cancelled. So you will be getting a value of pi square minus pi square. So that's what is with respect to the problem. Okay. So we will be completing this lecture with this. Okay. Stopping it over here.